Today we're going to learn about present value. Present value is taking a future sum and discounting it back to today. We remember with any time value of money module that if we have 4 items, we can find a 5th item. So if I give us future value, the amount we need in the future, if I tell us the interest rate we can discount at, if there are any payments involved in number of periods, then we can actually find present value. So let's walk through an example. And I want to first just congratulate you. You've become just absurdly wealthy for this example. Your favorite sibling had their first child, and you do a little math on the back of a napkin, and you decide they'll need $500,000 in 18 years when they start school. You think that you could earn 9% on a mix of stocks and mutual funds on a portfolio between today and those 18 years from today. And so the magic question is, how much would you set aside right now so that it would grow in $500,000 in 18 years? And we're going to assume it can grow at 9%. And this is where present value comes into play. We want to find the present value of that $500,000. So where do we start? Well, we're going to start with a present value equation. We take future value and we divide by 1 plus the interest rate raised to the nth power, where n is the number of years in this case. It could also be months though, so look out for that. And from there, it's a pretty basic algebraic equation. We take $500,000 and we divide by 1 plus 0.09 raised to the 18th. We get $500,000 divided by that annuity factor, and in the end you find, using kind of algebra, 105,996.87. You may be going, Craig, what does that mean? Well, what it means is that if today you invested $105,996.87 and you earn 9% a year for 18 years, you would have $500,000 in the future. The present value is a really neat tool, and when we look at it on a timeline, we see the same thing, right? $500,000 is the future, 18 is the number of periods, 9 is I, and then 105,000 is PV. And that's that relationship, right? 4 variables, find the 5th. Now in this example, we weren't adding or taking money out of that cash flow. So you'll see payment as 0. We're going to pivot to Excel now, and I'll walk you through using a basic Excel spreadsheet calculator, and we can see then how we put all this together in the end. But before we do that, just kind of one food for thought thing. What would result in a higher present value? So we look at that algebraic formula, future value divided by 1 plus I to the n. Well, a higher future value, right? If I needed $1 million instead of $500,000, right? That would certainly bump up PV. And then less interest and less time to compound. That would also bump up PV. Think about it, right? If I only had 4 years to get to $500,000, I would need the heck of a lot more to start with. If I could only get 1% instead of 9, I would need the heck of a lot more to start with. So basically what would change in that variable model? Higher FV and lower I and lower N, that results in a higher present value. Well, let's flip over to Excel and see what we can do. All right, let's pivot over to Excel. And when we do that, I want to take just a minute to review some fundamentals as we go into any time value money equation. The first off is to remember, let Excel do the lifting for you. So what I've done is I've shaded all the areas where I'll input a variable light blue, and that teaches me not to overwrite any hard formulas. So for this model, I've got the effective rate that's going to be used in the problem. In this case, the nominal rate was 9%. That's my market return, and it only compounds once per year. We're not doing anything tricky here, so 1 time per year. And you can go over here and you can say, okay, well, what was my goal? What was the future value? Well, it was $500,000, so 500,000. See this 0.9 carries over, and I have 18 years to do it. Now, payment matters with present value. We're going to cover that in a future video series. So for now, there's no money going in and out. And so we wouldn't really worry about, timing of that payment. So we'll leave that as 0 as well. And down here, we've got PV, right? And so we go ahead and use that PV equation. If you're going to be keying this in for the first time, you would do equals PV and then a colon, and Excel will take you through which variables go where. So our present value here, 105,996, it reflects as negative because that's what we would need to invest today. That would leave our wallet to grow to that $500,000.